After securing the shell feeding part, next we need to install the whole line positioning block, which is this part. This is a completed whole line positioning gauge. The two components above and below look like this positioning device. There is a groove in the middle, right here. Then this is the upper component, and this is the pressed groove, which fits perfectly with this groove. After assembling it like this, it should be flush and align with this groove. This is our press terminal. The final terminal needs to fit into this groove. Then, at the terminal's pulling force forming area, the area where we rivet corresponds exactly to this groove. At this point, we press the component at the inner knife position, which shapes the terminal. After installation, I need to achieve this result before inserting the shell. Installing it is quite simple. There are two screws here. Just lock it in this position. This component is locked above at this position with these two screws. If after locking the groove does not align, we need to adjust the main line. First, if we take the lower side as the positioning reference, because once it's installed, it won't move. Then, if the pressing plate does not correspond to this groove, we need to adjust the front and back of the upper pressing block. Adjusting front and back requires adjusting these screws. First, loosen these three screws, 12 and 3. Then twist this screw clockwise, and the upper pressing block will move inward, pushing it over counterclockwise. Then, adjust its front and back position to align with our tooth groove, matching this position. After adjustment, tighten the screws 1, 2, and 3. And there is a nut here that needs to be secured tightly. This is the debugging position of our whole line positioning device. After we finish feeding the shell here, we need to open the pointer. There are two sensors. One controls the vibrating plate. The sensor indicates the material's position. The one with the wire controls the vibrating plate. The one without this wire does not exist. This wire is for controlling the vibration. After opening it, we need to check the shell being fed and adjust the position of this shell. Is the position of the first shell aligned with our front positioning gauge? First, we touch the screen. There's a manual sealing position here, which allows us to observe easily to see if our shell aligns with the front positioning opening. Because every terminal of our glue shell must align with each positioning terminal. After our machine returns to position, we can click to manually release the shell. At this point, it will automatically feed the shell, bringing it to the front. After bringing it to the front, we can set parameters here. This is a shell insertion module. Find the insertion parameter here. After finding the insertion, we can click manual. This is for front insertion. Then we have a rear insertion with 2 ports. Here we have a plus and minus option. We can move this T-shell forward, touch this home and move it closer. This way we can easily see it from the opposite side. Let's check if our shell and terminal positioning gauge are aligned. If the positioning gauge is a bit low, we can raise it. Yes, there are 4 sets of positioning gauges on the line. Let's click it. This is also a servo adjustment. We can click to raise it up. If you click it and it doesn't move, it will rise up. You can see now that it has already risen. At this point, we can get a bit closer. This will make observation easier. If it's not aligned, like the shell and terminal positioning holes are off, we need to adjust the shell delivery position. This is the first shell delivery, just the distance for the first shell. If you are off to the left or right, the larger this data, the more it shifts left. This is the position for one-time shell delivery. The larger this data, the more the shell shifts to the left. If it's smaller, it will shift more to the right. I will visually check for you to see if it's left or right to adjust the first shell delivery position. Below are 1, 2, 3, 4, 5, 6, 7, which is the spacing between the shells. The spacing is based on the drawings, so we just need to get the spacing right. As long as the first one is accurate, the rest should be fine. We input our spacing here, then press and hold to write it in. It will all appear here. So what we need to adjust is the distance for the first delivery. There is also a fiber optic for shell detection here. What we installed earlier is a fiber optic to check for shells. This is for detecting the presence of shells controlled by 2 amplifiers. We can see the amplifiers showing green data. The green data is our set value, and the red data is the detected value. The role of the amplifier is to compare the actual detected value with our set value. If there is a difference, it will be greater or lesser. This way, it will send out a signal. Let's try this. If I remove the shell from under the fiber optic head, at this point, we can see that the bright red light is no longer on. When I sent it over, the red light turned on. It works by comparing this data. So when there are shells and no shells, the red area will show 2 data points. So we set the green value in the middle. There are 2 data points for shells and no shells. Then the green value is set in the middle between shells and no shells. When setting, there are 2 adjustments here, and you can set it accordingly.